Yes, I am not asking you to draw a perfect graph, but I am just trying you to explain how to visualize and imagine the problem statement. Okay. So, this is a very simple vector that has been given, right. So, you have 400 here and 500 here. So, let us say one division represents 100, 100, 200, 300, 400 here, right. So, 100, 200, 300, 400, 500 here, right. Again, when this is the x axis and this is the y axis, the unit axis, the unit vector along the x axis is I, the unit vector along the y axis is j. So, along x axis you have 400, this one, okay. Along y axis you have 500, this one, they intersect here, and therefore, this vector represents Vi, the initial velocity vector. Is that clear? Okay. And then the same goes here. This is minus 400 and this is minus 500. So, if you try to plot this vector here represents Vf. Is that okay? Right? A minus means the opposite direction. Now, the pilot started from here and went up till here, and he took 24 seconds. But the formula we are using for uniform circular motion is for a complete circle, and that is how we define the time. The time was time period. The time period in the formula is for a complete circle, it is not for a half circle. Also, the pilot in this problem covered a half circle. Therefore, the time period is not 24, it is the double of 24. Is that clear now? Yes. So, can you please take a picture? हो गया? Okay. Now, I am going to talk about chapter number 5. Again, chapter number 5, most of it is a revision of what you already know. So, chapter number 5 is about force and motion. Sorry. So, we have been talking about motion, right? We have been talking about motion in chapter 2, we have been talking about motion in chapter 4. What is motion? Motion, we have defined it with the help of terms like displacement, velocity, acceleration, so on. Now, we are also going to discuss the relationship between force and motion, because you cannot produce motion without applying a force. We know that for sure. If you are walking, you are moving, you are applying a force. If you are driving a car, you are applying a force. If you are riding a bike, you are applying a force, right. So, that is what this is about. In order to understand this, the simplest and the most famous laws that were given to explain force and motion are given by Newton. So, this is known as Newtonian mechanics, right. So, Newton's first law, Newton's second law, Newton's third law. Everyone knows this. Even if you are not a physics student, everyone knows this, right. These are very famous and very simple and very basic laws that we use in everyday life. So, what is the first law? What is Newton's first law? It is written in the book, but we can also discuss it. Yes?
If no force acts on a body, the body velocity cannot change.
Fine. If you are not applying a force on a body, the body will not move in simple way, right. Or the opposite of this is, if a body is moving, you have to apply a force to stop it. It means you cannot change the state of motion of a body without applying a force. You have to apply a brake if you want to stop it. Applying a brake is applying a force, okay. You need to apply the accelerator if you want to accelerate it. So, that is again another. So, this is also known as the, so nothing happens on its own without the application of a force, and therefore this is also known as the law of inertia. What is inertia? This is known as the law of inertia. Inertia is the ability of matter to change its state of motion. Okay. For example, a book lying on the table will remain on the table until someone applies a force to it. If you pick it up, you are applying a force. If you push it down, you are applying a force. If you do nothing, the book will not change, it will stay where it is. Right? Okay. So, this is the law of inertia. What is Newton's second law? Again, the Newton's second law is very simple but very useful, and this is very good. F is equal to, it gives you directly a relationship between force and motion. Again, remember, force is a vector quantity, acceleration is a vector quantity, and mass is a scalar quantity. Okay, what is the unit of force? Newton. Capital N, and it is defined as when we have a mass of 1 kg moving with an acceleration of 1 meter per second square, the force applied is equal to 1 Newton. So, that is the basic definition. Very good. You all know it. There is nothing new, there is nothing difficult, there is nothing strange about this, right? Okay. Now, when we talk about this, there is another concept that comes to mind, and that is weight. What is weight? Weight is a kind of a force, right? When gravity is pulling a body with a force, this is called the weight of the body. So, now you can understand the difference between mass and weight. When I tell you my weight in kg, it means I am actually telling my mass, not my weight. Okay. So, we know that in this case W is equal to mg. So, the acceleration in this case is the acceleration due to gravity. So, the force sometimes is also represented as F with a subscript small g, known as the gravitational force. Again, the unit for weight is not kg, it is Newton. So, but in everyday life we mix it up, right? If somebody asks you your weight, you tell them in kg, right? Okay. Now, let us look at Newton's third law now. Let us see. But before that, there is another thing we can look at. Yeah. Before that, let us look at two other kinds of forces. Okay. So, there is a force that is known as the normal force. Okay. So, this is given as F with the subscript capital N. So, what does this force mean? This is page number 96. Page number 96. What is the definition of this force? For example, a body lying on a table will experience a force that is perpendicular to the surface. So, normal also means mathematically perpendicular or 90 degrees. So, a body lying on a surface will experience a force downwards, which is the gravitational force Fg, and opposite to that force there will be a normal force perpendicular to Fg, which is known as Fn. If both Fn and Fg are equal but they are opposite, they cancel each other and the body remains at rest. If one of them increases, the body will move in that direction. So, that is the concept of a normal force. Okay. Now, if you go to the next page, this is page 97, figure 5.7. यहाँ पे है फॉर्मूला Fn is equal to mg. अगर ये दोनों इक्वल हैं, फॉर एग्जाम्पल इफ दिस